Good evening, good morning, and good afternoon, everyone. Depends where you are now. Welcome to our monthly Singapore.NET Developers Community Meetup in March 2020. I hope all of you are coping well in the current COVID-19 situation. We have not been in touch for a while, and I hope to bring some positive energy to our community by bringing back our monthly meetup. I'm Chun Lin, the event co-organizer of this community. I'm happy to have my teammates Marvin and Riza here today to help run this meetup together. You can always reach out to us on Twitter if you would like to join us as speakers next time in our meetups. So without the support from you all, our communities cannot grow to today's scale. Few months ago, we just celebrated our 5th year anniversary developers community. Woohoo! Last year, Marvin shared about this new initiative, which is meant to encourage more of you to join and share about different knowledge, ideas, or even your hobby projects. I will invite those who have already signed up to the program to join our Microsoft Teams discussion soon. So if you are interested to contribute to our community, please sign up through the URL shown here. Together, we learn better. In addition, if you like to code and you love to build something cool, drop by our community GitHub. Currently, we have some projects from desktop application to form recognizer or even to PowerShell. Or if you have some projects that you would like to share with the rest of the community, you can always submit them to our GitHub too. So in our community, we welcome all sorts of meetups. Some recommendations are listed here, including an online meetups like what we are doing now. Today, there's a great news that I would like to share with you all. Yes, it's us having a LinkedIn page for our community. Yeah. So with this LinkedIn profile, we hope to reach out to a larger group of professionals out there, and hopefully we can make use of the platform to help you easily add your contribution in our communities to your LinkedIn profile. The link to our LinkedIn page is up there. So since it's still now very new, I hope you can visit the LinkedIn page later to follow. Thank you. Once again, welcome to our 4th YouTube live session. And here is another good news to all of you. Yes, we finally have over 100 subscribers on our YouTube channel. And we received an award from YouTube, which is, no, not this one. Is actually we finally have a customized URL for our channel. So please visit this link and subscribe to our channel. If you would like to get notified, please also turn on the notification. Thank you in advance for your support. All right. In order to keep things running smoothly later, please remember to guard your privacy and abide the YouTube community guidelines. Feel free to ask questions in the chat, and speaker will answer them after the sharing session in the Q&A part. Today, we are proud to have Mete Atamel, the developer advocate at Google Cloud in UK, to be our speaker. So for those who were with us 2 years ago, Mete should be a familiar name to you. Yes, today he is back to our community to deliver another talk about serverless containers with Knative and Cloud Run. So without further ado, let's begin. Let's welcome Mete. Let me switch the screen over. Mete, you can
Yes.
take over.
Can you hear me?
How do I? Yes. Yeah, Mete, I can see your screen now.
Yes, and can you hear me as well?
Yes.
And people on the channel, they can hear me as well, I guess.
Yeah.
I'm assuming that's the case. Okay. And you see my presentation, right?
Yes.
Okay, great. Hello, everyone. For those of you who haven't seen me 2 years ago, my name is Mete Atamel. I am a developer advocate based in London. I was actually supposed to be in Singapore last week and this week, but unfortunately, we have a travel ban, and then that was followed by lockdown in London. I think it's pretty much the same in Singapore as well, probably. So yeah, so I'm in my apartment, but I'm still very happy that I can present to you today, even virtually, and hopefully later in the year when I visit Singapore again, hopefully we can have another meetup where I can be there physically. By the way, there's an echo in the background. Can you mute? Oh, I think you muted now. Okay, great. And I don't have any feed. Usually, I like my sessions to be interactive, but in this case, I think it's a little bit difficult to have questions because I don't have any interaction from anyone. So maybe what you can do is you can write your questions, I'm guessing in some kind of chat, and then the organizers can let me know at the end of the talk for the questions, and I'll try to answer them. All right? Okay. Containers with Knative and Cloud Run. First of all, the presentation is already online on my speaker deck, and here's the link. And then the demos that I'm going to show today on I'm going to share the links, all those at the end of my presentation. So you will have all the material at the end of this presentation if you're interested in exploring more. Now, first, let's do a little bit of introduction. Now, when we think about serverless, depending on who you talk to, you get different definitions of serverless. But I think there's basically two different ways of thinking about serverless. You can think of it in terms of operational model, in terms of how you operate your code. So when you think of serverless, you usually don't have to worry about the infrastructure that's kind of managed for you by the cloud provider. You usually take some kind of security granted, so you don't have to think about security from bottom up all the way yourself. At least the basics are there for you, and you expect to only pay for the usage, right? So it's not like a VM where you pay for things all the time. So that's kind of like the operational model of serverless. At the same time, if you're building applications, you're a programmer, then you can think of it in terms of a programming model. In this model, you're thinking of services that are event-driven, so some kind of event, like a pub/sub message or an HTTP call or something like that, that triggers your service. And usually we are talking about stateless services because as soon as you introduce state into your services, things become much more difficult. So in serverless frameworks, usually your services are stateless, but then you kind of externalize the state to something external to your service. Now, at the same time, we have these things called containers. So the idea of containers is that it's a way of packaging your application and its dependencies in what's called a container. And the beauty of the containers is that it gives you a lot of flexibility. So you can use pretty much any language you want, pretty much any library you want. There's this whole ecosystem around containers with projects like Kubernetes, Istio, Knative, and others. And then containers give you this context that you can replicate in many different environments, right? So whatever you run on your machine in a container, you can take the exact same context and run it in the cloud, and you can be sure that it's the same kind of environment. So you don't have to worry about replicating the same environment in different places anymore. Containers do that for you. So when you think about it, serverless gives you a lot of things out of the box. And because of that, you can iterate fast and you can go really fast when you're using a serverless framework. So it gives you velocity. But at the same time, you are kind of limited by the cloud provider. So whatever the cloud provider provides to you, if it works, great, you can use it. But at some point, it's not going to work. For example, if you want to use a certain language, or if you want to use a certain framework, or if you want to do something that's not supported by the serverless framework, then you're kind of stuck. And at that point, you'll be falling back to containers. And with containers, you get all the flexibility that you need, but you kind of lose the velocity that comes with serverless. So far, it's been kind of like a choice between the velocity that comes with serverless and the flexibility that comes with containers, but you couldn't do both, right? And that's what Knative and Cloud Run is for. So the Knative and Cloud Run, they try to bring serverless to containers, so you don't have to make this choice. So you can still get the flexibility of the containers, but at the same time, you can also get the benefits of the serverless framework that you usually expect. So you can kind of combine both. So Knative, it's an open source project built on top of Kubernetes. And the whole idea of Knative is that it tries to turn Kubernetes into a serverless kind of environment. So it runs everywhere there is Kubernetes. So it can be on-prem, it can be cloud, it can be anywhere you can run Kubernetes. You can install Knative and it works. Now, on the other end of the spectrum, there's Cloud Run. Cloud Run is basically Knative, but it's the managed version of Knative on Google Cloud. So Google basically created open source Knative, and they made it really easy to run on Google Cloud, and they call it Cloud Run. So if you are using Google Cloud already, then if you're using Google Cloud already, then you would probably want to go with Cloud Run because it's much easier. But then if you're in any other kind of environment, or if you want to run things on-prem, you probably want to go with Knative itself. And then there's something called Cloud Run on Anthos, which is kind of the middle ground between Cloud Run and Knative. It's Knative running on Google Kubernetes Engine. So if you want to stay within Google Cloud, and if you want to, but if you want to still stay on Google Cloud GKE, but if you want to run Cloud Run, then you want to use Cloud Run on Anthos. I have a notification. Let me just double check 1 sec. See if I don't think it's anything from here. Let me just double check my notifications quickly. Yeah, I think it's my messenger. So let me just turn it off quickly. So, okay. All right. So today's talk, it's mostly going to be about Knative open source initially. So I'm going to talk about Knative serving, Knative eventing. Then I'm going to switch to Cloud Run and show how Cloud Run is different than Knative. And then in the end, I also want to show you, if we have time, some things about Tecton pipelines, which is another project that came out of Knative, but now it's a separate project. So hopefully you will have a good idea of what Knative is, what Cloud Run is, and also a good idea on Tecton pipelines as well. All right, so Knative, what is Knative? As I mentioned, it's a Kubernetes-based open source building blocks for serverless. You can think of it as kind of like ready-made building blocks that you can install on top of Kubernetes, and it will turn Kubernetes into a serverless framework. And I'll show you demos of this and see how that works. It's an open source project, and it's on GitHub, so you can contribute if you like to. It's written, by the way, in Go. So if you need to know Go if you want to contribute. I'm a .NET developer as well, but I'm also trying to learn Go so I can contribute more. And the Knative stack looks like this. So at the bottom layer, we have Kubernetes. So everything runs on Kubernetes. On top of that, you need to install a gateway. So Knative, it doesn't try to solve networking problems. So it doesn't try to figure out how to set up networking for your containers, how to get traffic to your containers, and all those kind of things. Instead, it relies on gateways to do that. And the default gateway that's used is Istio, because Istio goes really well with Kubernetes. But then in the later versions of Knative, some newer gateways are being supported as well, such as Glue and Ambassador. Initially, when you use these other gateways, the Knative eventing wasn't working. But I think now they should work, although I haven't checked it recently yet. But if you're using anything other than Istio, make sure you double check that the Knative event thing works with them. Now, once you have the platform and the gateway, you can install the Knative components. So there's two parts of Knative serving and eventing. You can install them one by one, or you can install them all at once. It's up to you. And then you can use Knative as is, right, at this point. But then there are other products that are being built on top of Knative. So as I mentioned, Cloud Run and Cloud Run on Anthos are two of them. And there's other products from other cloud providers that are being built as well. So if you're already running in the cloud, you might want to check what Knative implementation there is for you, if anything. So instead of using Knative itself, you probably want to use the managed versions of them because it's much easier. Now, let's first talk about Knative serving. So Knative serving, what is it? It basically allows you to deploy containers in a serverless way, right? So what you do is that you create what's called the Knative service. And in this Knative service, you say, this is my service name. This is the container image for my service. This is my, my environment variables. And then you just tell Knative, please deploy this service for me, container for me. And then it basically creates the container, creates the pods, sets up the traffic, and then just runs your container in an easy way. So by just deploying this one service, you get a container deployed, you get traffic configured to go for it, you get automatic scaling, you get configuration and revision management, and then once you have multiple revisions, you can do traffic splitting. So you get all these features kind of like free by just using Knative. And the primitives of Knative serving is something like this. So at the top level, you have a Knative service. This is not a Kubernetes service, by the way. So there is also the notion of service in Kubernetes, but Knative service, it's a higher level construct, and it's not Kubernetes service. So I need to make the distinction. So in this service, you have a configuration for the service. And then when you deploy your service and its configuration, it's kind of like a unit. And then Knative creates a revision out of that service configuration double. And this revision will get all the traffic by default. Now, every time you change anything about the configuration, this revision and deploy it, Knative creates a new revision, and the traffic gets updated to that new revision, and so on and so forth. But once you have multiple revisions like this, you can also set rules here and do things like traffic splitting. So you can say, maybe 50% of the traffic goes here and the other 50% goes there, right? So the building blocks of Knative serving is basically Knative service at the top, configuration of the service. With these two, you got a revision every time you deploy. And then there's a route that points to the revision, and every change creates a new revision, and the route gets updated to that revision. Okay. So let's look at some examples, actually. For example, here I'm in Google Cloud Console, and I already created two Knative clusters. So this is an older cluster, and this is Knative 0.13, which is the latest version of Knative as of today that I created a couple of days ago. So I already have this cluster created. And just to make sure that our cluster is working, here I am in my console. If I do kubectl get pods and look at Knative serving namespace, this is where the Knative serving pods are installed. And as you can see, all the Knative serving pods are running. And then if you look at Knative eventing, which is the next Knative part that we're going to look at, you can see that they are running as well. So I have Knative installed in my my cluster. And what I want to do is, if you look at my, so by the way, I'm going to share this link at the end of my talk, but I have a Knative tutorial where I have the presentation already, and I show you how to set things up. So if you look at Knative installation, I just want to quickly show you how to install Knative. Oops. I want to actually go here. I have a setup folder, and with setup scripts that I already have. So to get a Knative cluster, first you need to get a Google Kubernetes cluster. I'm using that on Google Cloud. So I create the cluster, then I install Istio, which is the gateway that Knative needs. So in this case, I'm using Istio. Then I'm installing Knative Serving. Then I'm installing Knative Eventing. And then I'm also installing something called Knative GCP. So if you want to read Google Cloud project events, such as PubSub events or storage events, there is this separate project as well that you can install. So I'm doing that as well. And then you need to set up some service accounts, and you need to create some PubSub topics to listen to. So that's what I'm doing here. I don't want to get into details of the scripts, but just to show you the serving, like how you actually install serving, you can see that to install serving, I just point to some serving CRDs, and then I point to some serving core components. And that's pretty much it. And then there's some other things that I'm installing for Istio. But you can read this yourself if you want. And I basically look at the Knative documentation and created these scripts out of them so you can easily install them. And I keep them updated every time there's a new version of Knative. So that's how you get a Knative cluster. And now let's look at a Hello World example. So let's say you have a very simple app and you create a container out of it and you want to deploy to Knative. How can you do that? First, I create my Hello World application. I did this in C# and Python. And just to show you quickly how the code looks like in C#. So here I have my program.cs. And what I'm doing is I'm listening on 000 and port 80. So that's a Knative contract that you have to adhere to. So that's what I'm doing here. And then in startup, all I'm doing is that when I'm getting a request, I am looking at an environment variable called target. If it's there, I'm going to read it. And then I'll say hello target. And if it's not there, I'll just say hello world, right? So it's something very simple. And the Docker file is just, I'm using ASP.NET 3.0, and then I'm just using a sample Docker file from Microsoft Page. And that's it, really. So once we have that, I built my image, I push it to Docker Hub, then I create a Knative service. Now, this is the service that I was talking about before. As you can see, the API is Knative API, and the kind is a service. This is the name. This is the namespace, default namespace I'm installing to. And this is the configuration of my service. The image points to my image on Docker Hub that I already pushed. And as an environment variable, I'm passing the target, and I'm giving it value v1. So this is the value that I'm going to read and print out from my service. So let's actually deploy this. But before we deploy it, I want to watch something. So here I'm watching Kubernetes pod, Knative service, Knative configuration, revision, and route. As you can see, there's some pods that are already running. These are the pods that I need for eventing, so you can just ignore them for now. And then here I'm in Hello World folder, and then I have my service v1. So let's just apply the service v1. Now this says Hello World is created, and what you can see is that I have a Knative service that's been created that has a dummy zip.io domain set up for it. There's a configuration that's been created. There's a revision that's been created, that's generation 1. And then a route that's been created that's pointing to my service, right? And then finally, the pod on my service is also created. So all the things that I talked about, they're already created for me. If you know Kubernetes, and if you know Istio, you know that this is much simpler than using Kubernetes and Istio yourself. Because in Kubernetes, you need to, if you want to deploy a container, you need to create a pod, you need to create a deployment, you need to create a Kubernetes service. If you're using Istio on top, you need to create a gateway, a virtual service, and connect the virtual service to your Kubernetes service. So there's a lot of steps that you need to do just to deploy a container. Whereas in Knative, as you've seen, it's just one service that you define, and that's it. The rest is done for you. And actually, if we do a curl now, that URL, we should see, by the way, see the pod was terminating, and then another pod got spun up. So what happened here is that once we deploy our container, we didn't use it for 60 seconds. And then after 60 seconds, it scaled down to 0. So you get that by default. And then when we did a curl here, that spun another pod up immediately, and then that handled our request. So it's saying hello v1 now. So our service is running. All right, so that's Knative serving. Let's look at making a configuration change. So for example, as I mentioned, every time you change something here, that creates a new revision, and the route gets updated to that revision. So for example, let's just go and change the value of our target from version 1 to version 2 and see what happens. And then as a next step, let's also change our code from hello to bye and see how we can deploy the new code. Of course, whenever you make a change to the code, you need to build your Docker image again, and you need to push it again, and you need to come back to your image and update from version 1 to version 3 of your service. So let's do these actually. So now what I'm going to do is let's first apply the first change, which is the configuration change. So I'm applying that, and you'll see that immediately this creates a new pod with the new change. It also creates a new revision. This is generation 2. And then the route is now updated to point to the new container. So if we do a curl again, now you can see that we are updated to hello v2. Now, if you want to do a code change, as I mentioned, you change your code, push the code, and then update the image. So I already did that in service v3. Now, once we deploy that, again, the same thing. It will create the pod. It will create a new revision. And once everything is running, we can do a curl, and then we see by v3. So we did a code update. Of course, this is not how you update code in real life. What you want to do is that you want to maybe deploy a new version. You want to test it out, make sure that the new version works silently. And then once you know that it works, you want to route traffic to it gradually. And then once everything is working, you want to update to the new version and let it get 100% of the traffic. So you want to gradually ramp up traffic to the new version, right? And Knative makes this really easy. So there's all these traffic splitting rules that you can apply. So just to show you one example, one thing to note right now is that all the revisions right now, they have random names. So if you look at our revision names here, they all have random names. In traffic splitting, it's useful to have revisions with predictable names, and we can actually give predictable names to our revisions. So let me show you an example. So in this case, we have a service, and then we are giving our service a name. So if I add this metadata and name, and then I say hello world v1, what I'm saying is that basically when I deploy this service, I wanted its revision name to be version 1. That's what I want to happen. And then I'm also passing some traffic rules. So in this traffic rules, I'm saying that the revision v1 will get all the traffic, but then anything I deployed afterwards will get no traffic, right? So that's what I'm saying here. So let's just deploy this. Service v1 pinned. Now what you will see is that this will create a new revision, but now this revision has version 1. It has a nice name now that I can refer to. And then if you do a curl again, we'll see that we are back to version 1. Great. Now let's imagine that we want to deploy another version. Let's call this version 4. It's the same thing, except I call it version 4, and the target has the value version 4. But I still have the same traffic rules, right? The version 1 is getting all the traffic. So let's deploy the version 4 and see what happens. So if we do version 4, you'll see that we will have a new version created, version 4. And then if we do a curl again, now it's still version 1. So what happened in this case is that because of the traffic rules, we are still sending all the traffic to version 1. But version 4 is also deployed. And actually, if you come back to your URL and at the beginning add latest dash, you see that I can get to version 4. So I can test version 4 and make sure that it works. But then the main URL is still pointing to version 1. Now, at some point, if I want to direct traffic to version 4 as well, you can do that. So all you need to do is just go to your traffic splitting rules and then change the traffic this way. So here I'm saying that version 1 should get 50%, version 4 should get the other 50%, and everything else after them should still not get any traffic. So if we apply this, service v1, v4 split, now you won't see any more revisions being created because we didn't create a new revision. All we did is we updated our route to point to 50%, 50%. So if we do a curl again, now it says version 1, another curl, version 1. At some point, yeah, now it should say version 4. You can see that it's roughly, hopefully 50% of the time you're splitting traffic. So you can see how this kind of stuff becomes really easy with Knative. And then if we are done with our service, what we can do is we can just say Kubernetes delete Knative service all, and this will create hello world service. And then all of a sudden, everything will be cleaned and the pods will be terminated. And we are back to nothing, back to the pods for eventing. All right, let's see how we are doing with time. We're doing good. Now, this auto scaling with Knative is totally configurable. So for example, by default, it goes down to the containers scale down to 0. But if you don't want that, you can set minimum scale to 1, and this will make sure that your service runs at least one pod at all times. You might want that if your container starts kind of slow and you don't want to deal with cold start issues. You can also set a max scale. So in this case, I'm setting 5, which means that I will have 5 maximum containers at all times. The auto scaling itself, it's concurrency based, meaning by default, 100 requests will come into a pod, but then 101st request will spin another pod. But you can change that if you want. So if you change the target to 1, then this means that one request will be 101 pod, and then the second request will go to another pod. You can also change the type of auto scaling. So if you don't like concurrency-based auto scaling, you can use CPU, Kubernetes CPU-based auto scaling, and use CPU as your metric for auto scaling. So I show you how to do that here and how to test it out if you want, but I won't go through that here myself. And I guess another thing that I want to mention is that gRPC, which is an efficient protocol, binary protocol that's open source, is supported on Knative. And then there's also something called cluster local services. So right now, everything we deploy is public. But if you want to have private services where the service can only be called by other services within your cluster, you can mark your service with this label, cluster local, and with that, the service becomes private. And actually, let's look at that. I think I should have an example here. So I have service local. So if we deploy that service local, you can see that the service gets created, and then the URL it's a local URL. It's not like the URLs that we had before with zip.io domain, right? So they are not public URLs, and this URL is only accessible within the cluster, right? So that's how you can actually deploy a service internally. Let me delete this because we don't need it. There we go. And I think that's all I want to say with Knative serving. Now let's go to Knative eventing, but before that, I want to double check to see if I have something. I had some messages, but I'll close these. All right. All right, so that's Knative serving. That's the first part of Knative. The second part of Knative is called Knative eventing. And what Knative eventing tries to do is that it tries to connect event sources to event consumers, which are usually Knative services themselves, with some kind of flow in the middle. I know this is a very generic description, but Knative eventing really tries to be generic. It tries to read a lot of different kinds of event sources and connect them with different kinds of ways that we'll go through. Now, when you look at Knative eventing docs, it's a little bit confusing because it talks about event sources, it talks about channels, subscriptions, services, brokers, and triggers. And it's kind of hard to know like which one do I use and where. Because of that, I actually wrote a blog post recently explaining people how they should think about it. And the way I think about it is that there's basically 3 different delivery models in Knative eventing. I call them simple delivery, complex delivery, and broker and trigger delivery. Normally, this is the one broker and trigger delivery that you need to worry about. The other ones you can kind of ignore because they're there for historical reasons, and they're there in case something broker and trigger doesn't handle. But 99% of the time, this is what you want to do. But I want to go through this quickly as well, because there's some use cases where these can be useful as well. So in the simple delivery model, you have an event source, and you have a service. And this service can be a Knative service or a Kubernetes service. And you have the source sending events to the service directly, right? It's the simplest model you can think of. The good thing about this is that it's a simple model to think about. But the bad thing is that there is no guarantees on persistence. So there's nothing in the middle where the messages are saved. So if the source goes down or if the service goes down, the messages are lost. And there's no, it's one-to-one. So it's source to service. There's no way to kind of fan out messages, right? So if you want to do one-to-one messages where you don't really care about the persistence of messages, then it can work and it's simple. But other than that, it's not that useful. Now, in complex delivery, it's one-to-many. The model in this case is that you have the source, and instead of sending the messages directly to the services, it sends to what's called channels. And these channels, they can be in-memory channels, but they can be more persistent channels as well, such as Kafka or Google Cloud PubSub or something like that. And what these channels enable you to do is that, first of all, it enables you to save the messages if that's what you want. So there's some kind of persistence there. And then it also enables you fan out. So the services, the Knative or Kubernetes services, they can create subscriptions to the channel, and they can each get the message. So you can do one-to-many kind of deliveries in your cluster. Now, there's also another flavor of complex delivery called complex delivery with reply. And in this case, it's the same kind of idea where you have the channels and subscriptions, but also the services themselves, they can reply back to messages. So in this case, for example, we have a message that goes through to these 2 services, and then the service 2 replies back with another service. So when it receives a message, it says, okay, fine, it does something with it, and then it replies back with another message. And this message can goes through the subscription to another channel, and then from that channel, it can go to other services, right? So you can chain these as they go along. Now, this can be useful for some use cases, but at the same time, you can see that this is getting quite tedious, right? Because you need to create channels. I mean, all of these, you need to create them one by one. And actually, in my tutorial, I show you how to do this. But it can get quite tedious because you need to create subscriptions, you need to create channels, and you need to connect things together one by one. It can be really hard to maintain. So that's why they introduce broker and trigger delivery. So if you look at this model, this use case, the same use case can be handled in this new broker trigger delivery using something like this. So in this case, the source sends a message to what's called a broker. And a broker, it's something that gets injected into the namespace, right? So every namespace where you want to receive messages, you can inject a broker. So the broker receives the messages, and then the services who wants to receive messages from the broker, they create what's called triggers. And in these triggers, you are basically telling broker what kind of messages you want to receive. So you filter by the messages that you want to receive. So in this case, service 1 and service 2, they are both interested in these kind of messages. But then service 3, when it creates its own trigger, it's only interested in these kind of messages. So what happens is that when service 2 replies back with this kind of message, that gets back to the broker, but trigger 1 and trigger 2 will not get this red message because they're not interested in it, but the service 3 will get that. So you can see that this is much easier model to deal with. You're only dealing with a broker that gets injected into the namespace, and then you're just configuring triggers with filters so that each service gets the message that it needs, and then any service can reply to the messages. All right, I'm going to show some examples of this, but let's just go through some of the slides, and then I'll switch to demos. So we've been talking about these event sources, but what can we actually listen? What kind of events we can listen? There's a whole list. This is the full link where you can see the list here. But basically, you can listen to things like Kafka messages, AWS messages. There's something called cron job, which is useful for testing to send a message on a schedule. You can listen Google Cloud PubSub messages, Kubernetes events, Google Cloud Storage events. So there's a lot of things that you can listen. And there's documentation on how to set them up because all of them are slightly different. So you need to go through some steps to set them up. And then I should also mention that all the events that come into Knative, they get converted into what's called cloud events. So in this case, for example, we have FTP, GitHub, or Google Cloud Storage events. They all come in as different events, but then the sources, they convert them into a common format called cloud events, which is an open source event definition from CNCF. And in the end, this cloud event will have some common metadata, like spec version, ID, source, things like that. But the data of this cloud event will contain the actual event that you're interested in. And then from then on, the broker and on, you will be dealing with cloud events. All right, let me show you some examples of this. Again, on my tutorial, there's Hello World eventing. Let's actually go through that and see what it takes to receive events in Knative. So in this case, I'm skipping, by the way, you can see that I talk about simple derivative, complex with reply and broker and trigger here. So you can actually go through these and set them up yourself. But in Hello World, I'm just skipping all of that and just going with broker and trigger because that's what we care about. And what we want to do is that first we want to make sure that our Knative eventing is set up. And I did that already. Then you label the namespace with Knative eventing injection label. And by labeling your namespace with that kind of injects a broker into your namespace. And then you can check that your broker is there. And then you need to create an event consumer. In this case, I'm just creating an event display that all it does is that when it receives an event, it just logs it out. And you can look at the code here if you want. We push the image, it's on Docker Hub, and then you can create a Kubernetes service, or you can also create a Knative service. In this case, I'll use Knative service because it's easier. And then once you have that, you want to create a trigger that connects your broker to your service. So in this case, I create a trigger with this name, and then I'm filtering on this type. So this type meaning I'm only interested in event display type messages. I don't want to receive everything. And this is the service that will receive the messages. So once your trigger is ready, you can make sure that it's working. And then now, what I'm going to do in this case is that once I have my consumer running, I want to create another pod that I can log in and send a message. And this is what this pod is about. So I create that pod, and then I attach to it, and then you can send cloud events directly yourself. So in this case, I'm just using curl, and I'm sending a message to the broker in the namespace, and I'm just passing in this cloud event metadata that you need. And then in the data itself, it's just a message that says, hello, Knative. So I'll just pass it to the broker and then see that being received by the Knative service. So let's do this. First, let me go to eventing. Let's kill this. And event display. So first, let's create let's make sure that our broker is injected. So if I do kubectl get broker, you can see that I have default broker that's being injected. And then let's see if we have a trigger. We don't have a trigger yet, which is expected. So first, let's apply our Knative service. So this is a service that will receive the messages. And then let's set up the trigger. So the trigger connects the service to the broker. And now if you do a get trigger, you can see that the trigger is set up. It's connected to the default broker. And this is the URL. So this is the event display URL that where it will pass the messages to. So everything is set up. Now what I want to do is first, let's look at the pods. You can see that I have my event display pod. And then let's look at the logs of this. So let's do Kubernetes logs. And then it's user container, and then let's just follow it. So you can see that our event display is just waiting for an event. Now I want to create another pod. And in this pod, I want to log into it and send a message to the broker. So to do that, I need this kubectl attached. Let's get into pod. So now I'm in the pod itself. And then let's just copy this, the curl command. And then, so I am basically doing a curl to default broker, and I'm passing some metadata, and then the message will be hello Knative. So let's send that to the broker. And then you can see that immediately here, our service says event display received the event, and this is hello Knative 1, right? So it worked. So hopefully this gives you an idea on how things work. Let's clean these things up because I don't like things hanging around. So let's delete the Knative service trigger. And also let's delete the pod. Okay. All right. And another example I want to show here, and let's check the time. I still have time. Another example I want to show is that you can basically integrate your Knative service with pretty much anything. For example, in this case, I want to show you how you can connect Google Cloud storage events to a Knative service. And actually, I think I have a slide on this. So let me show you the slide. Yeah. So what I want to do here is that we have the users. The users can upload images to a Google Cloud Storage bucket. So Google Cloud Storage is a place in the cloud where you can save any kind of files. So once that image is saved, we can set this bucket to emit pops-up messages. So this will emit messages to a pops-up topic. And then we'll listen that message to Knative through Knative eventing. And this Knative eventing will pass it through broker and trigger to a Knative service. And the Knative service will make a call to Vision API. Vision API is a machine learning API that can detect the labels out of an image. So you give it an image, and it tells you what the image is about. So what we'll do is that once we receive this notification of this new image, Knative service will make a call to Vision API and display the labels of that image. But the important thing here is that we are connecting a cloud storage event to a Knative service doing some kind of thing like calling a Vision API. So to do this, what we need to do is first we need to create our code. You can actually take a look at the code here. It's a C# code here. I don't want to get into the details, but basically the important point is that we get the object, we get the event, and then we figure out where the URL of the image is. And then we create a Vision client, which is a client that you can use to talk to Vision API. And then we just say, can you please extract the labels out of this image? And this is the image URL. And then we get the labels back. And then we order the labels by score, and then we just log them out. So you can look at the details in GitHub, but that's basically what we are doing here. And then we create our image and push it. And then we create our service. This is a Kubernetes service, but you can also do Knative service. We create a trigger to connect the service to the broker. And then we also create a bucket to save our images, create notifications from the bucket to pops up so that when an image is saved, it sends a message to the PubSub. And then we can actually test our service. So let's actually set this up. So vision. Oh, let me make sure the broker is running. Yeah, so we have the broker. I want to create a Knative service. And if you do, you can see that the vision service is being created. So if you look at pods, it's container creating. And then let's connect that to the broker. So create a trigger. If you look at the trigger, we can see that it's connected to the broker. And then at this point, the pod should be running as well. Great. And again, let's look at the logs. So if you look at the logs of this vision, it's just waiting for something to happen. And now what I want to do is I have some pictures. Let's actually do this from console. So if I go to Google Cloud Console, I have storage. And then you see that there's a bucket called Knative bucket. And I have a picture here. So let's just upload another picture. So upload files, eventing, vision, pictures, beach. So I'm uploading this picture. As I don't know if you can see, but basically it's a beach with mountains and sunset, something we don't get to see nowadays in the flat, but hopefully we'll at some point soon. So let's upload this picture. Now what's happening is that this picture is being uploaded to the bucket. The bucket will send a notification to a PubSub topic. That topic will send a message. The message from that will be read by Knative eventing, and Knative eventing will pass it to eventually through broker and trigger to the Knative service. And Knative service, once it receives it, it will make a call to Vision API. So if all of that worked, you can see that our service received content. So this is the message that it received. And then from there, it figured out this storage URL. So this is the URL that it received. And then it says this picture is labeled sky, body of water, sea, nature, coast, water, sunset, blah, blah, blah. So it made a call to Vision API and get those labels, which is nice. So this just gives you an idea on the kind of things that you can connect with Knative eventing. So let's delete this again. Knative service and trigger. We're back to normal. Okay. All right. Now we are running out of time, but I want to maybe talk about Cloud Run now a little bit, show a quick demo of that, and then we'll probably skip the build part because I think it will be too long. But I can point you to my tutorial and see where you can learn more about the build. So far we've been talking about Knative, and everything that I showed you right now, it runs anywhere there's Kubernetes, so you don't have to run it on Google Cloud or any other cloud. You can even run it locally if you have Kubernetes locally. But the Cloud Run is the managed version of that. And the idea is that basically, same as Knative, brings serverless to containers, but in a much more managed fashion. And the main use cases for Cloud Run is public endpoints, if that's what you want, or private endpoints as well. So internal async workers, you can do that with Cloud Run as well. There's some contract that you need to adhere to with Cloud Run, just like Knative. You need to listen on 000, and you need to listen on port variable if it's there. And if it's not, then it's going to default to port 8080. Your server must start in less than 4 minutes. Your request time has to be 15 minutes or less, meaning when you receive a request, you need to reply back in 15 minutes. So you can't do like long-running 1 hour, 2 hour jobs on it yet. It has to be stateless, and everything has to be within the request. So you can't span threads and do other things in the background. That's not allowed. You have to do everything within the request thread. So if you can adhere to these rules, then Cloud Run is a really good option to do all the stuff that I show you, but in a managed way. And then there's more things like you get 1 CPU per container, but it can increase to 2 CPU. Memory starts with 256, but it can be up to 2 gig. You can handle multiple requests per container, which is different than other cloud functions or other Lambda kind of products, which is unique in this case. And then you get 1,000 containers by default. So it scales up to 1,000 containers, but you can set a lower limit if that's what you want. And you only pay for what you use. So you choose the CPU and memory that you need, and then you get charged per every 100 milliseconds. So if your Cloud Run is not being used, you don't get charged at all, which is really nice for occasionally connected apps. And for example, if you have 2 requests coming into your service like this, request 1, request 1, request 2, request 2, you only pay for the beginning of request 1 and the end of request 2. So you only pay for this time, even though your instance might be running, if your container might be running before this request, but you don't get to pay for that. You only pay for the request time. And this makes it really, really, really affordable compared to other things like VMs and other things. And as I mentioned, you can handle multiple requests. So it doesn't have to be like one request, one container. It can be up to like 80 concurrent requests that you can handle. And some use cases for Cloud Run, as I mentioned, public endpoints, private endpoints, but it can also be done like in an async way. So you can listen a pops-up topic or a queue, and when it receives a message, pops-up can call your Cloud Run. You can listen for cloud storage events. Same thing as I showed you with Knative. You can do that with Cloud Run. So when someone saves a file or deletes a file, they can send a message to a queue, and then from PubSub can go to Cloud Run. You can do scheduled events. So there's something called Cloud Scheduler, which is a cron job in the cloud, basically. And you can say every 10 seconds, I want my service to be called to do something like this. And finally, you can use something called Cloud Tasks. So you can create what's called these tasks, and then you can push these tasks to your Cloud Run services to process, right? And these tasks are asynchronous. And they also have things like built-in mechanisms to read-write tasks if something failed and things like that. So let's just show one example here. This is another tutorial I have that I'm going to share the link at the end, Cloud Run tutorial. And here I show how to set up a public service, how to configure the service, how to set up all these triggered services that I talked about. But let's just look at a public service for now. So you might remember, like, we deployed a Knative service publicly. How can you do the same thing with Cloud Run? So what you need to do first is that you need to build your image, just like we built our Docker image and pushed it to Docker Hub. In this case, you will be using gcloud build submit. So when you say gcloud build submit and point to your project and tag it with a tag, this takes your Docker file, and then it uses Google Cloud Build in the cloud to build your image, and then it saves it into Google Container Registry. So everything happens in the cloud with one command. And then you, to deploy the Cloud Run, you basically just say gcloud run deploy, give your service a name, point to your image, and then mention what kind of platform you want to deploy to. In this case, managed, but you can also deploy to GKE. And then I'm saying allow unauthenticated, meaning I want things to be public. So let's actually do this. Let me copy this and make this bigger. Service name hello world public, and let's actually make sure that I have my image already. So if I go to Google Container Registry, yeah, I have hello world already here. And you can see that 1 hour ago, I pushed an image here using gcloud build. So it's already there. And then all I need to do is just let's run this command. Gcloud run deploy. And now this is basically doing the same thing that we did before. It's creating a new revision for our service. It's routing traffic to that revision and setting the IAM policy, meaning it's making it public, right? But the key difference in this case is that we haven't created a Kubernetes cluster. We didn't install Istio. We didn't have to set up a YAML file, nothing. We just said, just deploy this container. And then when that happens, if you go to Google Cloud, And if you look at Untitled Cloud Run, you can see I have a bunch of services, but Hello World Public is the one that we just deployed. And then you can see that this is just deployed. I have multiple revisions that I deployed on at different times. I can see logs on my service. If it loads, it's integrated with Stackdriver. So you can look at the logs. You can look at the YAML. So this YAML, you can see that it's a Knative YAML that you can take and deploy to Knative if you want. But we don't have to do that here. Just everything is done for us. And then I get a URL, so I don't have to worry about setting DNS myself. If I click on it, I just get hello v1 again. So it's very simple. And then if we come to edit and deploy new version, you can change things. Like you can, for example, you can change maximum requests, you can change request timeouts, you can change the memory that you have. You can add variables. So you can see that I have my target v1 here. I can do more. And then you can connect to things like Google Cloud SQL, things like that. Yeah, so this is Cloud Run in a nutshell. And then I show you other examples like how to do storage triggered services and things like that. But I suggest you go through that yourself if you want. I don't think we don't have that much time left. I'm already talking for like an hour now. Last thing that I want to mention is building. And this is, I'm not going to go through this, but I just want to mention it so that you are aware. So there used to be something called Knative build. So there was Knative serving, Knative eventing, and Knative build. But then Knative build turned into something called Tecton pipelines. And what Tecton pipelines is that basically it enables you to define pipelines within your Kubernetes cluster. And these pipelines, they can do builds, like they can do things like building your containers and pushing those containers to places like Google Container Registry or Docker Hub and stuff like that. So you can install Tecton into your cluster and do all that kind of stuff yourself. There's some primitives with Tecton, like task, where you define what should happen, and task run, where you kind of take the task and provide inputs and outputs to your task. And then a pipeline is a chain of tasks, and then service accounts to authenticate with places like Docker Hub. So you can use these to build your pipelines. And in my tutorial, in my Knative tutorial, I show you how to do this. So how do you do a build and push to the Google Container Registry? How do you do a build and push to Docker Hub? And how do you use Canico, which is a way to build container images without having to have Docker installed on your machine. So you can take a look at these yourself. I won't be covering them here because we are out of time. And as I mentioned, all the resources are here. So if you want to get the doc, get the deck here, it's on speaker deck. If you want my Knative tutorial, it's here. And this is Knative Dev, the official Knative documentation. And then Cloud Run tutorial is here. And then this is the official documentation for Cloud Run. So hopefully this was useful to you. It was definitely useful for me to be able to speak to you from my flat. It definitely makes the day more interesting. And let me see if I can figure out how to see your questions in case you had any questions. So let's just see.
I think it's a
where would I look for
the on the YouTube.
On the YouTube, okay. So let me go to YouTube. I think we have it here. All right, so. Oh, it's here, okay. When we split traffic with 50-50, is it possible for us to make it sticky so that the same visitor always see the same V1 all the way or V4 all the way? No, there's nothing sticky about Knative. Actually, there's no guarantee for any request to end up anywhere, really. I mean, it's based on Kubernetes and Istio, and requests coming in can go to any pod. There's no guarantee on that. Now, of course, there might be a way to set things up in the underlying Istio where things are more sticky, maybe. But out of the box, I don't think there's anything to support that. Also, in 50/50 traffic, will it direct the traffic to another one if one of them throws exception and down? Well, I think what will happen is that, say a user is directed to a pod, but the pod is down. I mean, if the pod is down, it will be taken out of the list of pods that are receiving requests. But if a user already ran into the problem, they will probably get an error, and then when they try the next time, they shouldn't end up in the same pod, because the pod will be taken out by Kubernetes, basically, from traffic. All right, another question. Should anyone have any question? Oh, no. All right, I think 80 max concrete requests only. Yeah, I mean, as of now, it's 80. But all the defaults in Cloud Run, they are being changed or they are being added. So all the things that I talked about in terms of like the limits of Cloud Run, they are being extended. For example, I think by default I said you can only run requests for 15 minutes. I think that's being increased to like 1 hour now. So these max concurrent requests, at some point it might be increased, but the last time I checked, it was still 80. Another question, is Knative also can be run in another cloud service like Azure or AWS? Yeah, I mean, Knative can be run on anywhere that supports Kubernetes and also the gateways that I mentioned, Istio and others. So as long as you can install Kubernetes and the gateways that are prerequisites for Knative, you can use Knative. That's a key thing that I should stress. It's an open source project. It runs everywhere. That's why I like it, because I don't like to be tied into things. Even though I work for Google Cloud, I still like the idea of being able to run things wherever you want. So that's the case with Knative. All right, I think that's all the questions. Unless someone has one last question, please write in the chat. If not, thanks a lot for listening. And if you have any further questions, feel free to reach out to me on Twitter or something, and I'll be happy to answer more. All right, I think I'm done.
Testing. It seems to be.
Oh, there's some echo.
Test. Okay. All right. I think it's good.
I think when you start talking, it's better.
Yeah.
Yeah, there's no echo now, so it's fine.
Okay. Maybe I should. That doesn't make sense. All right. Thank you, Mete.
Thanks very much for
Mete. Okay. Sorry about it.
Yeah.
Okay. Thanks for the amazing sharing. I hope. Let me go back to my slide. So I hope you all find this sharing useful, especially on how .NET developers can now run .NET Core applications on Google Cloud as well. But it seems, Mete, do you miss something, like sharing with us how you migrate the .NET framework, ASP.NET Web to ASP.NET Core and run it on?
Yeah, I mean, I was supposed to do that, but I realized that it would be a 2-hour talk if I did that, so I kind of took the part out. But if anyone is interested, I did a series of blog posts on Medium, where I think it's like 4 blog posts on this topic. So people can read it there if they're interested in that journey.
Okay, cool.
Yeah.
Maybe later I will share the link on the YouTube as well.
Yeah, if you look at my name on Medium, you should see like 4 app modernization 4-part blog series, and they can read that.
So it's this one. Okay. Alright, so now our live streaming is coming to an end. However, before that, I have an announcement to make. Okay. Next month, our meetup will be on April, which is Wednesday. So, same as today, we will start it at 7 p.m. on YouTube Live. So I hope to see you all day. Later, if you are free, please join us too. Okay.
Sure.
Once again, I would like to thank Mete Atamel, Marvin, Riza, as well as all of you from different places in the world. Thank you very much, and I hope you enjoy the session today. Oh yeah, the sharing is automatically recorded and will be published later by YouTube on this same link. So just check it out later on this page. Finally, I hope that you and your loved ones stay healthy and stay safe during this period. See you all next time. Goodbye.
See you. Thanks.
Thank you, Mete. Let me off the